Excellent. So welcome to Detroit's inaugural event. It was supposed to be a dry run, but we are now streaming, so I guess that makes it actually the first event for Detroit.
We have 80 people in attendance today.
250 people are here. It's a gigantic room. We can't show you for privacy's sake, but it's huge. So I want to start out by giving special thanks, mostly to Ryan, aka Honey Boy, being the persistent nuisance that he is to keep pushing me to get this actually going, because otherwise it would still just be a thought project we were doing. To Paige for volunteering to kind of co-chair. She helped get this all going today with the logistics and what have you, and has been helping ensure the security is being met. And then of course to Brett, we all know him from Southfield. He is sacrificing his free time with family and everybody else to be here tonight to make sure that we can stream. So big thanks to the three of them to help me get this chapter going. And then to all of you who came out. All of you are actually Southfield people, so I appreciate you being here to help make sure that the logistics run. Going forward, the off-site was cool for food and drink. I don't know if we'll keep doing that. It looks like it might be easier to just have people here, but we need to figure out more of that, and we can talk about that offline a little bit more. So moving in, I know that Brett has mastered his initial speech. He talks about other organizations and what. I don't have all that. Maybe next time. There are other organizations out there. The first one that comes to mind is DC 313, also operating here in Detroit. They're a small organization, the Detroit chapter for DEF CON. Focusing primarily on hack the box type activities. So a lot of red team type stuff, headed up by Infinite, which you can find in our Detroit channel as well. So hit him up if you're interested in that kind of thing. They are also new and looking to grow, so make sure that you hit them up. Great organization going on there. And then there's also ISSA, is that right? I don't know, there's other organizations. I'll have more info on them next time. So with all of that being said, I wanted to actually do a talk today as opposed to just figuring out logistics. And with Detroit kind of, I hope, being tailored a little bit more towards students. So down here in Detroit, we have Wayne State University. Central Michigan University also has a campus down here. Grand Circus, which is a coding boot camp, they have locations down here, and we'd like to get developers involved. So what I'd like to do is kind of set the tone for the Detroit chapter talks, which is really helping people that are either new to security or interested in security or doing roles such as programming where security would benefit them. And so tonight we're going to be talking about Splunk. It's the program that every job description says that you need to have. And it is the program that is the most expensive. Never mind the light show rave that's going on. I was pretty sure we had that figured out earlier. Apparently not. So what I wanted to do was go from zero knowledge in Splunk, like don't even have it installed on your computer, to getting it installed, getting some data uploaded, and learning just kind of the basic syntax, or what's called SPL in Splunk, and so like the Splunk procedure language is what they call it. So the SPL, get that going so that you can actually start running analyses. So what we're not going to be doing, and on the seventh day, Jesus was like, blind everyone. And so what we're not going to be doing is analyzing logs. So you can set Splunk up, especially on a Windows machine, to directly plug into all of the logs that Windows has. I didn't do that. I want to show you how easy it is to just upload a small amount of data across multiple data sets and actually be able to use that to start just learning the syntax. The goal here isn't to learn how to mine through logs of data. It's not how to do big data mining. It's not how to do threat hunting. It's how do I use Splunk. So with that, we dive forward. So if you go into your favorite browser and just type in download Splunk, you're going to be presented with the first link that you should click, which is just download Splunk Enterprise for free. Big word being they're free. And ignore the hotspot internet that I'm on right now. So in order to do this, you're going to have a Splunk account. So you would just fill in your information here, agree to the terms and click create your account. But if you already have one, go ahead and just log in. I don't think either of those are right.
It was just Bryan.
Do you need a corporate account to sign up to download this stuff?
You do not. So I used my corporate account because we have a deal that allows us to get a developer license that is a little bit better than the developer license available to everyone else, which we'll get to in just a second. So check with your organization. If you currently work for a company that uses Splunk, check with them to see if the part of the deal is an ongoing developer license with your organization, because that might be available to you. So I would be very surprised if PwC didn't have that. Seriously, Dashlane, I'm good. So come in, it automatically detects that I'm in Windows, I presume, either that or it was just first. But you can see that it's available on all operating systems. Because I'm running Windows 10, 64-bit, I chose to download that, which gives you the MSI file. I don't need to run it because I've already installed it, but the wizard to help you install Splunk is very straightforward. I would recommend clicking on the advanced options, because then you can go in and like change the username that's going to be logging in, set the password, and all of that. It'll also give you a chance, if you have a little bit more knowledge than I had, to set up Splunk such in a way that you can collect logs from remote machines. So the way that I installed Splunk, it will only collect logs from the machine that it's currently hosted on, but you can set it up so that if you're at home and you have multiple computers on your network, you can set it up so that it'll collect logs from those computers as well. Yeah.
So in terms of sending system logs over into this Splunk version that you set up, are you using WinCollect? Are you using a pre-configured log forwarder, or how are you doing it if you have multiple computers within your home?
So the question was, how am I collecting the Windows logs? Am I using WinCollect or some other pre-configured approach? And the answer is that I'm not. So in getting this set up, I didn't want to connect it to my Windows logs yet. I wanted to first familiarize myself with just the basics. And especially for the purposes of this talk, which we're going to get into, or what I mean in just a second, I wanted to make sure that we were dealing with a small enough amount of data that when you leave here today, you can exactly replicate what I'm doing. So what I mean by that is the Splunk license without the developer license will give you 500 megabits per day of data ingestion, right? Not a whole lot. The developer license that is not commercial based will give you 10 gigabits per day, and our license gives us 50 gigabits per day. So that's why I'm saying that you should check with your company that you're at to see if they can give you a deal on the developer license. But even at 10 gigabits per day on like your home network, you're probably going to be okay. But here, the data that we're going to be looking at in its entirety is only 61 megabits, or megabytes, I'm sorry. So you can fully ingest that in a single day and get going right away. So you download the MSI, yeah.
One good thing to note, if you do have a large amount of data, like several gigs of data, you can ingest it, but as soon as you hit midnight and it checks the licensing, then you'll no longer be able to ingest any data. So you can do small amounts, less than 500 a day continuously, but if you have a large amount, if you get it all ingested in one day, you can get that successfully, but you won't be able to ingest any more data after that.
So it checks it at midnight?
At midnight.
Okay, and so is like the 10 gigs per day an average over 30 days? So like,
It's per day, so you'll get one warning, and then after that, depending on how much you go over, then it'll just cut you off.
oh, all right, well, don't go over then. So yeah, you download, you go through the wizard, you're good to go. And then what'll happen is it will launch you, and I don't know how readable that is for people on screen and here in the room, but you can see that it launches on localhost port 8000. For anybody who's running Splunk on Enterprise, that you might notice that that's a little bit different. The port that it gets run on, from what I've seen on Enterprise, is 8089. So just something to be aware of. It doesn't matter for what you're going to be doing at home when learning this, but just something to keep in mind. And when you come in, the first screen that you'll be presented with looks like this. This is your landing page. So on the left are what are called your apps. The only thing that's installed by default is search and reporting. Plenty of apps out there are available. Most of them are geared towards ingesting data from another source. So threat intel feeds, Twitter feeds, anything like that. Yeah, Ali?
Do the apps actually count towards your daily limit, depending on your license? Okay.
Brett says no, and he's more knowledgeable than me. So I say no. Yeah.
Is the Find apps also where you'll see the community-made apps, like for like VMware or like Carbon Black and stuff like that?
Yeah, that'd be my guess. So in full disclosure, I haven't tinkered with the apps yet here because for what I wanted to show tonight, search and reporting was good enough. Going forward, and also mind you, like the title of the talk, right, is like Splunk A through F. The idea being that I'm not going to teach you everything A through Z about Splunk. Like there's stuff that we're not going to go over.
What do we pay you for?
It's weird. I haven't gotten a paycheck yet. So when you say pay, what do you mean?
We use our dues.
Yeah, the Detroit chapter will be paying. It's equivalent to city taxes. So I haven't downloaded any of the apps just because it wasn't necessary for tonight's talk. Like we're not going to go over data models. We're not going to go over T-stats. We're not going to go over anything like that. We're just looking at the basics. So again, some of the stuff I haven't dived into. But to answer your question, presumably yes, the Find More apps is where you would find community apps around like VirusTotal and things like that. So once you've downloaded this, and you're on this landing screen, you should currently have no data in your machine at all, or in your instance. So what you're going to want to do is click on Add Data.
Much empty.
What?
Much empty. Much empty from Reddit. And there's nothing there that says much empty. So
I couldn't parse the words you were saying, and it sounded foreign. I was like, what are you talking about?
Jeff taught me some Chinese.
Much empty. So up top, you can obviously follow guides for onboarding popular data sources. This is likely some of the wizards you would want to go through if you wanted to import your Windows logs, your Mac logs, your Linux logs, right? We see stuff for networking and operating systems. These are probably the two that you would be most interested in for a home instance. Again, for tonight's talk, I haven't looked at either of those. For me, I have data in CSV format. So what we're going to be looking at tonight is, if we go to projects, Splunk Flight, you can see here I've got several CSV files that I'm going to be uploading. Yeah, Ryan?
I was going to say, answer Ollie's question about getting information from another source to the indexer. Actually on the page behind right there, the forward, you can add forwarders to the devices, and that will then send the data to wherever your index is. That's off the topic of what you're doing, but I wanted to answer that for him.
So if I wanted like Windows logs or like stuff from my router.
So like whatever device you have in your network that you want to forward logs, and I know there's other ways to do it too, but you can literally download, like have
it's an agent
scripts, you can download a forwarder to put onto whatever operating system.
So the forwarder just sits on the device that I want to send the data from?
Yeah, you know more about that.
Cool. Okay, so what, let's not actually click it though. So what Ryan is saying is that you can get forwarders, and Ali says that they act like agents, and you install those on the devices that you want the data from, and essentially what it does is just forwards the data from that device to the Splunk instance. Now, do you have to set up, I'm assuming that you'd have to like set up the indexes and like the parsers for that data coming in?
Select exactly what you want being sent over into Splunk.
Okay.
And how often you want it sent in.
Gotcha. Okay.
And it's a very lightweight application.
Cool.
Great thing about the forwarder too on Linux and also Windows, you can ask for other information. So you can say for every minute, every 5 minutes, every hour, give me all the running processes. Give me all the netcons. Give me So it's almost like having, you know, you're sitting right at the computer and you just want to keep the status of everything.
Mac's a little harder to parse and can be a challenge.
Okay. I'm assuming that most people will be operating on a Windows or Linux machine, but that's good to know that Mac is probably going to give you a little bit of trouble, which is almost never the story that gets told. Mac is always normally pretty easy.
There's one other thing. You can't open ports on this, so in cases of like a Cisco device, you can't put an agent on. You can just forward the syslogs. You'd have to tweak it, but you basically open a port. You basically do 514 or whatever you want, and you just have it open on this, and it'll direct it right into there, and it'll just slurp it up.
Okay, so what Brad was saying is that with Cisco, you might not be able to put a forwarder on the Cisco device. So what you would do is you would open up a port, say like 514, and you would just forward the syslogs that way so that it would slurp it in.
How are you remembering to repeat the questions? I never.
I don't even know what I said.
That's why some of us are leaders, Ollie. So,
Ollie left channel.
going back, just to make sure that everybody's on the same page, go ahead and click the upload button. This is how we're just going to choose files from our computer. And click select file. So it's going to open me up into here. The first thing that I might want to add, and I'm actually going to go through this process, I'm going to add a data set I don't have in here yet, is NYC flights. And so to quickly, right now is a good time to go over what we're going over. So what we have is 5 different data sets about New York City flights from the entire year of 2013. So we have one data set that deals with the flights. So each row holds flight data about where it originated from, what was the destination, were there any delays, when did it take off, what was its time in flight, etc. We have another about the airlines, which will give us information about the actual airlines themselves. Another about airports, which will give us information about the airports. Planes, which gives us information about the planes. And weather, which will give us a breakdown of the weather at each airport for each day. Now, the weather for the airports is only for the 3 airports in kind of like the tri-state area of New York. So we're dealing with JFK, LaGuardia, and Newark's airport. So we just uploaded the nycflights.csv. We see down here that it says that it's done. And up here tells us the steps that we're on. And so what we want to do once that's done is just click next. This is going to tell us to set our source type. And so what you're going to want to do is wait a second for it to load your data. And so it's gone through, parsed that out, grabbed everything, and you can now preview the data. So you'll notice here, Splunk is a time-based index machine, right? It loves timestamps, and this is because Splunk deals with machine-generated data where time is everything. What I found is that when uploading a CSV, it will always just take today's date and then just make it 6 a.m. And I haven't figured out how to change that. So if we go over, we have a column called time hour. That's the actual date and time of the flight. So what I might want to do is specify that that's the timestamp. So right now, it is configuring the time based on a configuration file, which you find in Splunk's like system files. We won't go into that today. Other options are auto, the current time, which is, I think, self-explanatory, but we're going to do advanced. So the default system time zone will just read the time zone from your OS, right? So here we're Eastern Standard. The timestamp format, you're going to have to understand what like strip time and strafe time looks for. And those are things like %Y versus %Y. So a capital Y is a 4-digit year, a lowercase y is a 2-digit year. So our format, if we go over to the time Z, or the time hour, is a 4-digit year hyphen the month hyphen the day, the capital letter T, the 24 hour format, so it's not a 12-hour format, it's a 24, that's what the capital H is for. If you had a 12-hour format, it would be %I. colon, minute, colon, second. Now, I already have this set up, right? So what you would do is you come down and you'd say time hour is my field that is a timestamp. And once that's done, you would click Save As and give it a name, a description, and leave the app alone. Go ahead and just leave that as system, and leave the category alone as well. So just give it a name, a description if you want. I've already done this, so once you have it, you can search for the format that you've already set up and select that, and it sets everything up for you, and you can go ahead and just click Next. Now what that does not do is override that underscore time field. That's still just going to be there. So for the sake of this data, that doesn't matter because we're not going to be time boxing our data using, and we'll point to what I mean later, but we're not going to use like Splunk's time indexing capabilities to subset our data. We'll do that on our own if we want. So the rest of this stuff you can leave alone. So the host is going to be a variable that gets set for you, and it just chooses the name from this host where the information is coming from. Here, that's just my computer. It's just going to assign it a host name and say it came from there. Index we're leaving as default. You can create a new index if you want, and the indexers are a good way to subset where your data is coming from later. We don't have enough data to worry about that. We'll leave it alone. So you can go ahead and click Review. It tells you it's an uploaded file, the file name, the source type that it used to format the data that was in there, the host and the index, and you just hit Submit. It uploads the file. This normally doesn't take this long, I'm sorry. Ali, you had a question.
Looks like you can also parse JSON files using Splunk.
That does not surprise me.
And convert it directly to a table without having to script anything.
All the card-like data comes in as JSON.
That saves a lot of time.
So once you've uploaded, you have a few options. Start searching is what we're going to dive into. And now you're good to go. So the first thing it does is you can see that it says source equals nycflights.csv. That's the name of the file that we uploaded. That's our source. Host was that pre-assigned value that gets set to us. And source type is that value that we chose from the drop-down that specified how we were going to parse the data. Because like these, the source type and the host, aren't necessarily unique, if we're looking to only deal with a specific data set, say weather or planes, best to deal with source, because that's going to specify exactly where the data came from, and that's the unique identifier. So when you run your data, there's a couple things to know. The first is that when using the UI, so when we're right here in the Splunk app, each search is actually prefaced by the word search. Splunk does that automatically for you though, because it knows that it needs it. Now there are instances where that's not going to be the case. If, for example, you were going to use something like input lookup, that pipe needs to be the first thing, such that what I mean by that is if that's going to be the first thing you do as an input lookup, you wouldn't do something like search or search star. It doesn't need that, it just wants the pipe. And again, that's something that we'll go over if we were to ever do like a G through Z kind of course, but just know that the search needs to be first almost always, but it's implicitly there. Additionally, Splunk treats every separate thing. So here we have source, host, and source type. The and, the Boolean operator and in terms of the conditions that you're searching by, the and is also implicit. So if you were doing something and I'm going to use sources that are already uploaded, but we haven't uploaded ourselves just now. So if I was going to do something like this, I have to specify or to say that it can come from either one. But if I do this, I'm specifying that the data has to come from both. Now, that's not going to happen because our data, each record only comes from a single file, so that should actually just return no results. But if we specify that it's an or, we should get the sum of the results that we have in our flights data, which is like 336,000 records, and from the weather, which is like 28,000 or something like that. And you can see that it runs through, and what we have down here on the left are fields that Splunk defines as interesting fields. Interesting fields are defined as fields that have greater than 50% coverage. I think it's 50%. In this data, you're going to find that it's probably closer to 100%, 88%. But in actual data, you might have fields that are very sparse, not always there. So if you were looking at web logs, different fields within your header string can be or cannot be present, right? And so if you're parsing out, say, the content type, that's not always going to be specified in your header. And so what it might be is that a bunch of missing data, and if like say 95% of the data for content type in your header is missing, Splunk is not going to consider that an interesting field because with so much missing data, there's not a whole lot you can do about it. So starting with your interesting fields, you can get a sense of what variables are available for your analysis. You can also then click on any of those and it'll give you a breakdown of those values. So we see the top 10 days, assuming that this is coming from our flights data. The number one day for flights is the 18th of the month. So without even running any analyses, we just grabbed the data from our sources. Splunk will already or automatically start running analyses for you. So we see there's 12,263 flights that took place on that day, accounting for about 3.4% of the data. And you can do that with any of the variables over here. Now you might be interested in the other fields that aren't considered interesting. You can go ahead and click the 10 more fields down here and go through and start looking, and what you see is the event coverage will tell you the percentage of records for which that field is available. So the temp is 7.2%. Now that's not fair to say the 7.2%, and the reason being we brought in two different source types. So with the weather having substantially less records than the flight data, that 7.2% is of all of the records that came back. So just something to keep in mind when you're looking at multiple indices, and then also considering like what is an interesting field. So, that's how you start narrowing down on a day. So in addition, the default thing, when you just type, source to get your records, there's no statistics being done, nothing fancy, nothing like that. So you just get what's called raw data. So each of these with the caret next to it is considered an event, and it is just parsed from the raw data. So you can click the caret, go in and just look at all of the values. But all of this isn't all that interesting. What we really want to do is start running some analyses. So the first keyword that you're going to want to know is table. So we're just going to deal with the flights data, and what we really just want to see is all of the data that we might have seen it in Excel. So you just do table star, and that returns all the variables. Now it's also going to include variables that Splunk created for you. So we specified the timestamp, and so it created variables like the hour of the date, the month day of the date, the minute, the actual month itself, second, weekday, things like that. So that's cool, we might want to use that, but that's not what our original data looked like. But table is a good way to get your data out of like that raw format and into a more tabular format that most people are more used to looking at. But if you want to really start analyzing data, stats is the keyword that you want to look at. So stats is just a basic analysis type tool. You can do min, mean, median, standard deviation, distinct count, things like that. So let's say, for example, we wanted to know how many airports are in there as an origination out of all of our data. And so what we have, by using DC, that's short for distinct count. So it'll take your variable origin, go through all of the different values that are in that column, take the distinct ones, and so basically run like a dedupe on it, and then just count how many unique values are in there. If you wanted to see what those values actually were, you can just run a count and then specify your by variable. So the count, if we left off by and just run stats count, that's just going to tell us how many records are in our data. But what I really want to know is how many records are in our data for each origin, how many for each airport. And so the by will do that. Or we can use multiple variables to say, I want to know maybe like the most common originating airport to the destination airport, like what are the most common flights? If you run that, you'll notice that Splunk does nothing to try to sort the data for you. It just goes through, grabs the data where it can. Without going into too many details, the whole MapReduce thing just ensures that you're not going to get sorted variables or sorted data back unless you say sort count. So sort is another keyword, does exactly what it sounds like it does. And then you specify the variables that you want to sort by. So you can do more than one variable. So maybe I want to sort by origin and destination. So what it'll do is it'll first sort by origin. So all of Newark's airport shows up together. And then the destination is in alphabetical order. If you want descending, you just put a negative symbol in front of it, and that specifies that this field immediately following the negative symbol I want to be in descending order. So one of the cool things that Splunk does is that it will automatically generate visualizations for you based on the analyses that you run. So you start out on the statistics tab, and that's anytime that you use table or stats or anything like that that might aggregate your data in any way, you'll get this statistics tab. The events tab, because you're in smart mode. We're not going to go into what that means, but let's just rerun this into verbose.
You sure?
It's really quick.
Huh?
It's really quick.
So now we see that we actually have the events, which is just what we were seeing before like we ran our aggregation. So you can go back to the raw data if you want. We have the statistics, and then for the visualization, we can see that it automatically chooses the column chart. We can switch that to be something else if we want.
What's it look like in a pie chart?
I hate all of you. Numeric data required. You guys are the worst.
What do you got to do to fix that?
I don't know where his anger comes from.
Angry all the time.
So it might actually do a pie chart if we do just stats count by origin.
Ooh.
Ugh.
How pretty that is.
Take a picture of you.
We got a different color.
You just
No numbers.
seriously
How
do a
can you
pie
tell what's
chart.
there?
I can't believe I just did a pie chart. I can't believe it's possible in Splunk.
And it was streamed and recorded.
It was streamed and recorded. So I want to go to a different analysis that I ran. I don't think this was it. Let's actually go back to here. So again, we're just going to break it down by origin and destination. So we're basically looking at counts by pair. So in your visualization, one of the things that I actually really like about Splunk is that you can use what's called Trellis.
What's that?
So Trellis will facet your data. So what you see here is 3 different visualizations, one for each origin airport. So remember, we only have 3 unique airports that are coming out of the tri-state area. And then on the x-axis, we have all of the other airports that, that we have destinations to. And so then it'll take the count, and on each plot only give you the count by airport for that originating airport. Now, one thing that you can also do is down here for scale, you see where it says shared? What that means is on all 3 graphs, they have the same y-axis. So even though the biggest value over here is only 6,100, it still goes up to 15,000 because you want to have that standardized scale across all 3 plots so that you can make even comparisons, but you can turn that off if you want. So if you go independent, it now looks like Newark is on par with the rest, but the y-axis is half as large. So be careful when doing that. It's easy to draw incorrect conclusions. But you can also go into format. On the x-axis, you can go ahead and give a title. Let's just do custom, and let's say that like that's airport. And on the y-axis, title, custom, number of flights. And so just like that, we've now adjusted the titles on our graph. It's good to go. I still haven't figured out how to print that or even export it, but it's here in Splunk, it's yours.
Right there, that little download button right there?
Yeah, but I think that downloads the data.
Let's try it.
So like even if you click export, I don't think that you can export a graph as a CSV.
Click that button.
Snapshot.
Click that button.
Yeah, you can use your snipping tool, absolutely.
You can export it as PDF.
No, see, it was the data. We'll see. Oh, ooh, that's going to get you a raise with your C-suite. So here's another one that I ran. This one is a little bit more complicated. So I want to use this one to introduce a few more keywords that are going to be beneficial when you're doing analyses. One is where. So in the original line of your SPL, you have search. After that, and we'll get into what a pipe is in just a second, but once you start piping, you actually have access to both search and where. I still don't fully understand the difference between the two. The Splunk documentation is not great on it. What I've gathered is that if you are searching within a column for a field, so say for example, we wanted origin to be JFK, you would not say where origin equals JFK. For whatever reason, it doesn't like that. You'd want to use search instead. And it'll search through all the data and it'll look where origin is equal to JFK. The documentation, like I said, is not clear on when to use it. It says to avoid where when possible, but I found that a lot of instances you actually still need to use where. So if anybody has feedback on that. So like for example here, you can't do a search is not null. That only works with where. But because it's a comparison, which is what Splunk says you should use where for, which is those comparisons, we're going to say where is not null dep underscore delay. So the dep underscore delay variable in our data is the departure delay. So what we're doing is we're going to start with the origin airport and look at the departure delay. And so we only want to deal with records where that's not missing, right? We don't want to assume that there was 0 delay just because it's missing, because in our data we actually have 0 values. So we're just not going to deal with it. And then we're going to go back to the keyword that we've been seeing over and over again, which is stats. And we're going to calculate the mean of the departure delay. And you can use this keyword as to rename the variable. So if you don't use this, your variable will actually be called mean parenthesis dep underscore delay parenthesis, right? Which is a lot to type out. So you can rename it at the same time that you calculate it. And you can also specify your by. So instead of looking at the average departure delay over all of the data, I want the average departure delay for each airport, which is why the by origin is in there. And then, let's actually, no, we'll leave that. So then the rename is another keyword that you should know. So right now, our variable is called origin, and origin holds the airport that we're looking at. I'm going to rename that to B airport. And the reason I'm doing that is because in the next line, I'm going to use a keyword called append. So now's a good time to talk about the pipe, where the pipe works just like in the bash pipe or anywhere else that you might have seen it, in that it will take the output from what's on the left of it, or in this case, what's above it. It will take the output from that and feed it into what's on the right. So we take our search for where the source is equal to flights, and then out of all of those events that come back, we feed that into a where clause that says, okay, filter this out where the departure delay is not null. Those records then get fed into the stats variable. The stats, or I should say function, the stats function then aggregates that data. So you're no longer dealing with, say, 300,000 records anymore. You now only have 3 records, one for each of the origin airports. That gets fed into rename, where we just rename it. So now what you have is a data set with 3 records, and we're going to append more records onto that. We're going to basically append rows on. And we do that with what's called a subsearch. Subsearches are done with the brackets. So we want to append, but what I want to append is the results of an entirely different search. So you'll notice that I have to specify search in the beginning. I actually don't know if I have to, that's a lie. Source equals flight, so we're going right back to the same data that we were at before. But this time I'm going to use the arrival delay. So this is now the how late was the plane getting to where it was supposed to be going. We're going to still take the mean of that, but we're going to rename dest as airport again. So the whole point was to get the names to be similar to each other, so that when you run that, you actually just end up with 2 columns, one column for all of the airports that are in there, and then one column for the average delays. The idea being that we have our 3 airports that we were dealing with, those are our origins, but then we also have all of the destination airports. And I'm just looking at the delays across. For the first 3, these are the departure delays, right? This is how late they were to take off. Here, this is how late they were to arrive. But I wanted to just see the delays for each airport side by side. What that allows is for a pretty easy visualization, right? You don't even have to do anything. You just click visualization. It's already in the column format. And we can already see that there's about 7 airports with negative delay time, meaning that the flights arrive early. And we know that they are arrival delays because I looked at the delay times for the tri-state ones, and they are all within like 20 minutes. So LaGuardia, JFK, not great. So if we then move on and start looking at, I want to save that one actually, and start looking at some of our other tables. So let's actually look at so we're just going to look at the origin and destination real quick and just see that these are all 3-letter codes, right? And that's great if you know them but not everybody has all of them memorized. And so what if you wanted to use the actual name of the airport? So one thing that we have, oh wait, hold on. Is the actual name for the airport in a different table, right? Our airports.csv. The question becomes, how do I take the variable name in one data set and get it into as a variable in my other data set? Now, one person might say, well, just use a join, right? Like if you have SQL knowledge, if you have worked with relational databases, et cetera, you might just say, well, just join them. They have this common variable. Here it's called FAA, and in the other it's either origin or dest. Just run a join.
There's an Amtrak train, or Amtrak plane.
Or there's an FAA code for an Amtrak station or.
Our New Haven Rail Station,
What are you talking about?
Springfield Amtrak
Like Penn
Station.
Station is
Oh.
rail, Amtrak is rail.
I think your data's messed up.
I didn't make the data.
You need an FAA code for the station for some reason.
Data cleaning is in Splunk G through Z. All right, attend the next talk. So with Splunk, joins are very, very expensive. Splunk is not a relational database. It doesn't like joins. It messes with the MapReduce, and so you should try to avoid them at all costs. So I use them later, don't you worry. And so what we can do is I know that this is data that I'm going to want to use. So I create my table, and the next thing I can do is just make what's called a lookup table. So you pipe it into output lookup, and this is going to create a lookup table for you. So let's just call this airports.csv. And then now,
Or trains.
yeah, or trains, planes, trains, and automobiles. If I run my input lookup, all of that data is there. Yeah.
Wait, can you put your input lookup the same name as the source you already have? So this is called airport CSVs, and you did the input lookup and you named it airport CSVs again.
Yep, so the question is, by naming my input lookup with the same name as the source for the airports.csv data that I have, does that complicate things? And so a simple question to ask, or a simple way to test that is to just check. And so we see in here, I only have the data FAA and name. So if I can pull one of the variables from the original data, then I know that that data still exists.
You just spot check some of your abbreviations, they're good.
And so we have the TZ still in there. So it did not overwrite that. And so now what we can do, if we take flights.csv, and just run that real quick, we get what we expect, our two columns of the airport codes. But what I can do now is say, well, I want to look up a value from airports.csv, and what I want to look up is the variable FAA, but I want you to call that origin because I need it to match the variable name that we're going to be appending to. And what I want you to output is the name variable, and I want you to call that origin name.
In the event of duplicate names or invalid syntax in the search parameters, does it give you like any assistance or any guidance on what you may or may have not done wrong?
I have found Splunk's error messages to be grossly misleading. Earlier I was trying to create a lookup as a KV store, and all it said was bad attribution. Told me I could inspect the job if I wanted. I went in, I looked at the search logs, nothing. And so I found the errors to be very lacking. I don't know if that's different for you, Brett.
Debugging is the biggest PIA.
Yeah.
So the best way is to take as, you're going through the pipe, and you have your data, is to break it down to the simplest and then keep on adding and validating the data to make sure you're not mangling it somewhere.
So use programming logic essentially to write a bit of the code,
Yeah.
Yeah.
test it out, add to it.
That's right.
Yep.
Throw in some extra variables, have some checks and balances to make sure. Guys started getting some funky results and had to do exactly that to try to trace back.
Yep. It's not pretty.
No, there's no trace command, there's no.
And I'll show, and we're going to go over a single gotcha in just a second, that this is how Splunk handles.
Just a couple, I'm holding you to it.
No, just one. It's big enough to be two, though. So what we see is that the origin name gets brought in for all of these. And what we can do is we can do that again. We're going to use the same variable, but this time we're going to have it call itself dest, because that's what we want to append to. And we're going to put out the same variable again, but this time as the dest name. And if you hit control and then like the // key, it pretties up your text for you.
Nested ores.
What's so pretty about that?
And so now we have both names for the data that we want. Now, here's something. Brett mentioned that, we ran into some issues and we needed to like backtrack and figure out what was going on. One thing to note is that you can tell how many results you get by the number that's here in parentheses, right? So we know that right now we have approximately 169,000 results that have come back, right? If I just sort this
336 now.
by origin and dest, oh, thank you.
It was that though.
I wasn't looking at the screen. With just doing a sort, how many records do you expect to come back?
Same number.
We would expect all of them to come back. We're not doing any filtering. We're not doing any aggregation. We're not doing anything that would mess with the data. So if we just sort, I wanted to actually finish this time. I got burned before. No, I know. Spoiler, it's only going to return the 10,000.
Just sort in order. So it only does the first 10,000?
Sort in Splunk, by default, only returns 10,000 results. That was a big FU in some of the analyses that we were running, where we were expecting like millions of results coming back. We weren't paying attention.
Can you override it?
You can. Great question, Ryan. Can you override it? It's super intuitive. You just add the number 0.
Makes perfect sense.
Right.
Is that the manual?
Buried deep, yes it is. I don't get it.
I did not know that.
You just add the number 0.
There's a lot of functions that will limit itself to 10,000, I've noticed.
Yeah.
Sub-searches, which
Really?
can be confusing. So if you're like, hey, I need this set of data, here's appending another set of data, that subset of data will only give you 10,000 results. Or until it hits a specific timer. It is configurable to change that, but you don't want to set it to unlimited.
Are you then like dumping the unsorted data into something else to then properly sort?
It just gets rid of it. It just doesn't care. Like it sorts everything and then just returns whatever the top 10,000 are.
No, I mean you and your process. Are you then, like let's say you took the data that was before sort, you export it, and then you sort it with something else?
No, so here you see how by adding the 0, so we, instead of just sort origin comma dest, we do sort 0 origin comma dest, we get all of our records back. We get all 337,000 records back. So to reiterate, if we remove the 0 and just sort by the 2 columns that we want to sort by,
Right. I was just going on the assumption that you have a function or something else that is limiting itself to 10,000, for instance, and it won't do anything but 10,000. Are you then kicking that data out to something that can then sort it the way you want it, or?
so
No, you as in the literal you.
so
If it won't do what you want it to do, are you exporting the data from Splunk and then doing it?
I
the
do.
other way? Okay, that's
So
what I'm asking.
I have R and Python both connected to Splunk's API. So if I find that it's not doing what I want, which is often the case excuse me, with visualizations, I just export it out.
The pie charts.
Yes, it's all pie charts. Because what I found is that the visualizations in Splunk are not great. So here, one of the questions that I might want to ask of the data is there a correlation between the weather and the delays of a flight? Seems like a pretty common question that should be able to be answered by this data, right? So here you can see that I'm using two new keywords that we haven't gone over yet. The first is eval. Eval is how you make new variables in your data. So here I'm saying that the date is equal to strafe time, strip time. Ignore this. This was something to do with the data and the way I read it in, and like it was just how I had to do it in order to get the date the way that I wanted it down here. But you should be familiar with what strip time and strafe time do. The other one that I'm using is join. So like I mentioned earlier, if you're coming from a SQL background, you understand how joins work. You understand the difference between left, inner, and outer. I'm not going to go into that here because this isn't a talk on SQL, but we are going to join, an inner join, we're going to join our weather data. And so you can see that I'm taking advantage of the shortcut on sort to make sure that we get all of our data back. And this is what our data looks like. So we have the origin, where the flight was coming from, on what day, how long was the delay. Here, I hope that's not in minutes. I don't actually know on the data. And this is the temperature that it was at the airport that day.
That makes sense.
Celsius or Fahrenheit?
Yes.
Kelvin?
It's 20 degrees Celsius.
So if we go, it starts yelling at us that it doesn't know what to do with that data. Too many results. That should have been a simple scatter plot, and let's actually just turn off Trellis. Maybe it doesn't like that. That's a scatter plot in Splunk. Not great. What you'd actually want is your x-axis to be either temperature or delay, the y-axis to be the other one, and you should see some relationship between the two variables if the temperature impacts delays. So this is why I say that Splunk is not that great at visualization. So if you have a way to get your data out and you can visualize it, I'd recommend it. I plan on doing a talk later maybe on how to connect an API to Splunk in order to do that, but that one's a little bit more advanced. What I wanted today was to show you how easy it is to install, upload some CSVs, and just start tinkering around with your data. I don't want to do what I did last time, which is talk for an hour and a half, so I'm going to end it here.
High charts for the win.
Yeah. So again, the whole point was to hopefully have you confident enough to go home, realize that you can have Splunk on your own computer. I did save all of the data in
I saw your wrapper. It's pretty nice.
Don't talk about that in public.
Splunk API wrapper for clarification.
So in my sec talk, April 2019 on my GitHub, all of the data that you want is there. Ooh, actually, I will show you one more thing. I promise this is super fast. So because it's possible that you might mess up, the reason that I uploaded this data. So if we just say source equals nycflights.csv, this is the data that I showed you how to upload earlier. But if you noticed when I was doing all of the analyses, I was using flights.csv. That's because I already had the flights data in there and I had called it flights.csv. So you can see that it has the same amount of records as 337,000. I actually don't want that data anymore. You can just pipe it to the keyword delete.
Now,
It deletes all the data.
do you need special privileges to be able to delete log data?
No, I mean, I mean, at work, yeah, probably. At your home instance, no. And so then what you can do is just search star stats count by source. And so we see that that NYC underscore flights.csv is no longer a source in the data. Ryan?
Any favorite how-tos or high level just targeting documentation besides like their Splunk documentation?
No. So I have been forcing myself to go through the Splunk documentation to try to learn what I can. Now a coworker swears by like the .conf videos. So every year there's a Splunk.
Like documentation itself.
Oh, they have
Like,
documentation too?
But your eyes will bleed. There's a
Okay.
lot.
There's several I sent you when you first started, and I think you as well. There are some PDFs that kind of go over the basics.
Cheat sheets.
And then there's the cheat sheets, there's a basic book, and there's a free book that's out there by Splunk. So if you're interested in that, you're welcome.
And then Ali, do you have another question?
Well,
Oh, okay. So yeah, you know, go home. Well, your hand was raised, that's what it means. Go home, install Splunk, apply for the developer's license. You don't have to have a corporate email to get it. Set it up, you know, try to get it connected to your computer's logs, get some real data going in. But I'd recommend starting out with the flights data and just start asking interesting questions, right? Like what's nice about the flights data is that everybody understands how flights work, right? We understand that it starts at an airport, it ends at an airport, and we know that we can ask questions about it, that we should be able to reason what the output looks like. And that's gonna be, I think that's gonna help you embrace Splunk faster than trying to dig through logs where you might not know what you're looking at.
Looks like you grabbed some International Air Transport Authority. Not only does it have flight data, but it also, like you said, has like train station data and whatnot. So the data's not dirty. It's just extra stuff in the IATA database.
Fantastic. So yeah, go out, play, have fun. And then I'm always open to questions if you want to know how to do anything in there.